Good afternoon and welcome. I'm Ron Leonard here at Rhodes State College, and what I'd like to do in the next 15 minutes is talk to you about robot frames, but specifically to the FANUC robots we have here in our labs at Rhodes State. So the objectives of this presentation will be to get you to know the Cartesian coordinate system, or maybe just refresh something you already knew. And then help you understand the most common user frames used not only by FANUC but by most robot manufacturers, and that are the world and joint coordinate modes. And then some very specific user frames or frames that reference frames that are used by FANUC robots that can help you be more productive when you come to write your programs. And those are the tool, user, and jog frames. So these are all going to be very specific to a 6-axis robot, which we've talked about before, and how 6 servos turn the 6 axes and manipulate the robot in its orientation and position. So let's start with the Cartesian coordinate system from the 17th century, René Descartes, codified for geometry, how to find something in space. So on a piece of paper, flat piece of paper, 2 dimensions, he outlined 2 perpendicular axes, x-axis and y-axis. So I can find any spot on that piece of paper in that plane by simply giving 2 coordinates, the x-coordinate and the y-coordinate. But in the world the physical world that we're in and that the FANUC robot is in, it has 3 dimensions. So we need to add a 3rd axis. We add the z-axis. In robot reference, we define the x-axis as forward and reverse, and the y-axis is side to side, perpendicular to that forward and reverse, and z is up and down, which is perpendicular to that xy plane. So this is how we're going to tell the robot where it is in space, and that's how 3-dimensional Cartesian coordinates find a position in 3-dimensional space: x-coordinate, y-coordinate, z-coordinate. So these different coordinate frames on the robot controller are selected using the robot teach pendant. The teach pendant has a button. It's labeled COORD, coordinate. And you can change your coordinate frames at any time by pressing the coordinate button. Each time you change it, it cycles to the next one, and then it returns back up to the top. So this is very useful when you're programming, because there are times when different frames will do different values for you. You'll be able to select between joint, world, tool, user, or jog frame. So let's start with joint mode. We mentioned that this is a 6-axis robot. The 6 joints are energized by 6 servo motors. And so the easiest thing for the robot to understand is if we move each servo and each axis 1 axis at a time. So if I just turn the base, if I just rotate the elbow, if I just spin the wrist, those are easy for the robot to understand because they're very simple signals to the servo drives to turn just that axis. It's also very useful to you, the programmer, if what you're doing lends itself to doing things 1 axis at a time, such as avoiding something or arranging a certain orientation. So to get the orientation of the 6 axes exactly the way you want to, it makes sense that you would jog 1 axis at a time until you got exactly what you wanted. So to use the teach pendant, the robot has to be in teach. You have to have the live man switch in the center position. You have to hold the shift key down. And then there are 6 pairs of blue buttons labeled J1 minus, J1 plus, J2, J3, J4, J5, J6. This is how you jog the axes. If I want to jog axis 3 in a positive direction, I would press the plus J3 button and it would jog until I let go of the button. So when we talk about manually moving the robot, we really want no surprises. So by having it labeled as such and defined as such, then you, the programmer, will have no confusion as to what it is that is going to happen when you press a certain button. So when would we use the joint mode? Well, if we have a motion that is primarily one or two axes that do most of the motion. A cylindrical path would be an example where I'm moving in a circle, and that circle is centered at my joint. So I just have an easy motion of moving that joint. So that would be one example. It's very useful when you're in manual mode, and then what you save as far as your points will be executed in the way that you told the robot to execute it. So it doesn't matter whether you use joint or some other mode to teach it. So when we talk about joint being useful, it's really useful when you're teaching or when you're in manual to move the proper arms the way you want them to move. So an example of that might be in a car body. I worked for GM. We had a lot of situations where we had welding robots, and we had sealing robots going through openings in the car or the truck body. And so if we were in manual, we really wanted to make sure we didn't hit anything. And so it was easier to visualize moving joint at a time, rotate this, rotate that, rotate this, rotate that. And then we were sure we knew what was going to happen. We weren't going to have any surprises. We weren't going to have any collisions. So the reference frame that is most intuitive to you requires the robot to do some interpolation. And that is the XYZ, or the world coordinate system. So in the robot's world, its X, Y, and Z is at its base, centered in the robot looking out. And I mentioned that X is forward, it's the robot's forward. Y is left, it's the robot's left. And Z is up, it's the robot's up. You might have the robot hanging upside down, in which case Z might be down on a gantry robot, something like that. But no matter how you orient the robot physically, its world coordinates is the center of its world. So its origin 0, 0, 0 will be at the base of the robot. So we're going to use this right-hand rule, and it's very easy to use this. You carry this wherever you go. So it will help you when you're teaching to remind yourself what is X, Y, and Z. Just remember, it's the robot's origin, not yours. So if I'm facing the robot, don't think that X is that way. The robot's pointing at you. The X is positive, is coming at you. So that X, Y, and Z, when I do move that robot in any of those directions, more than one axis is going to move, all right? It's going to be a nice smooth motion because there's really good interpolation that says I've got to move joint 1 so much this way, I've got to move joint 2 so much this way, I've got to move joint 3 so much this way, but I'm going to do them at different speeds so that they all go in a linear fashion and get to that point all at the same time. So it's quite an intelligent algorithm to take X, Y, Z motion and turn it into joint 1 through joint 6 commands to the servos. So again, in manual mode, we're going to use that same teach pendant. We're going to use that save live man switch. We're going to use that same shift button. And we're even going to use those same 12 buttons. Only now, if we look, they not only say J1 minus and J2 plus, but they also say minus X and plus X, minus Y plus Y, minus Z plus Z. So as you would expect, when you press plus X, the robot's going to move in a straight line away from itself. And if I hit minus Z, it's going to go straight down. And the robot controller will do all the interpolation to move all the proper joints at the right speeds and proportions to make that a smooth motion. So we can use the position screen. If I hit menu and I hit position, I will get that position that's on the screen. And I'm getting 6 readings, not just 3. So there are 6 things that are important. X, Y, and Z are obviously important. That's where my tool center point is in space. But then there's also the orientation. And the orientation of the robot faceplate, it can be very, very important. So we take those angles, rotating about the x-axis, rotating about the y-axis, rotating about the z-axis, and they're called yaw, pitch, and roll. It is much better if you just think of it as clockwise and counterclockwise around the x-axis, clockwise and counterclockwise around the y-axis, counterclockwise and clockwise around the z-axis. Because you're already working with your right-hand rule. You're already working with x, y, and z. And so knowing the rotation on these axes, you can use your right-hand rule. So it's actually better if you think of it that way. But when you look on the position screen, it says W, P, and R, and that's what that stands for, yaw, pitch, and roll. But it really means rotation about X, rotation about Y, rotation about Z. X, Y, and Z are in millimeters. Rotation about X, Y, and Z is in degrees. If I switch that mode from world to joint, it'll show me the rotations of all 6 axes in degrees. And again, if I'm in joint mode, I'd like to see that. I like to see what's moving. So rotating about X, the buttons actually have the little arrows to show clockwise and counterclockwise. And this, you can use your right-hand rule, or you can think of yaw, pitch, and roll. I recommend you use the right-hand rule. So where might we use the world? Well, anywhere I got some kind of period of straight lines. So in painting, we want to go in a straight line, then we want to increment, and then we go in a straight line, and increment, go in a straight line. So that kind of lends itself to X's and Y's. So tool frame is a really, really powerful thing, and some others do this as well. But if we just do one thing, if we take that X, Y, and Z from the base and we move it up to the tool center point, which is the point of interest, the point that's actually doing the work, some interesting things happen. I'm still going to get those straight line moves of X, Y, and Z, but now I can be much more comfortable with my orientation, because if I rotate around the axes at the base, this guy's going to swing around. But if I rotate around the axes at the tool center point, a cool thing happens. The tool center point stays fixed, and then everything else rotates around it. That's really useful if I want to find the right angle to seal or the right angle to weld. So that's called the tool center point, and it's different depending on the application. I talked about a welding tip. Here's spot welders. When they come together, I make that my tool center point. If I spray, it might be 12 inches off from the applicator. That's where my paint is most important. It might be a gripper, where it's the center of the gripper. Whatever your end of arm tooling, then you would make that the tool center point, because that's what you want to orient. That's what you care the most about orienting about. So I gave you 2 good examples with seam welding and seam sealing. To follow the seam, sometimes I have to orient differently as I go up and over and around. So if I'm doing these very complicated motions, it's real easy for me to change my orientation just by rotating around the X, Y, and Z that's right at the tool point. A user frame, this is uncommon, and it's a very powerful thing FANUC has done. So now I'm going to take that XYZ, take it away from the robot, but instead of the tool center point, I'm going to put it on my fixture. So if I find a spot on my fixture and make that my origin of my X, Y, and Z, I can teach all my points in nice straight lines that are relative to my fixture. But also, if I ever have to move my fixture, I don't have to reteach 100 points. I just have to move my user frame. And that's a simple procedure that FANUC gives you to teach the origin and the X and Y and calculate the Z to find the right-hand rule of the user frame that you're going to use for your program. So another example might be, I have 2 identical workspaces. I can set up 2 user frames, 1 for each one. I can teach my points and I can copy. Jog Frame is kind of a momentary tool, or an elective tool. Every frame I talked about before, you not only could use it to move the robot, but you could also teach your points in that frame. So the jog frame is just for jogging. It's not for storing the points. This is useful if just on a temporary basis when you're first doing a complicated part. You want to create a number of jog frames so that you can get some nice straight lines and then save them in world coordinates, and then from thereafter you can touch things up in world coordinates. So we learned about the Cartesian coordinates. We learned about the different coordinate frames: joint, world, tool, user, and jog. Not only what they are, but how they're used. Thank you.